Hello everyone, this is section 7.1 continued. We're going to do an example of finding the confidence interval from a list of raw data and then derive the formula for and then look at an example of calculating sample size. So what I'd like for you to do is to get your calculator and go to a list and spreadsheet. This data represent a sample of assets in millions of dollars of 30 credit unions in southwestern PA. We're going to find the 90% confidence interval of the mean. But unlike the previous examples, the sample mean, the standard deviation isn't given to us, so we're going to use our calculator. So just very carefully and double check your list. Go to list and spreadsheet. Remember to label X at the very top of your column. And then just go down the first column and enter in this data. All right, and pause the video if you need more time to type this in. Once you have this typed in, just go down to one more cell below all the data and then go to the menu for the stat calculations because we need to get the sample mean. Now for this, we're going to use the point estimate of the population standard deviation. So like I said, pause the video again if you still need more time to type this in and then run the stat calculations. All right, so if you scroll up through all the stat calculations, now if you take a look, the raw data is taken out to the hundreds, so we need to take this out one more place value to the nearest thousandth. So our sample mean, X bar, should be 11.0906 if you're looking at that on your screen. So we're going to take this to 11.091. Now we're going to go to our sample standard deviation, so you should be looking at the SX. So we're going to use that as the best point estimate of our population. Even though our population standard deviation is below, we're going to use this because it just came from a sample. So we're going to assume that our population standard deviation is the 14.405. All right, so again, we are going to calculate a 90% confidence interval. So that was really the only difference between what we were doing last week and what we're doing right now. We had to find those two values. So we want a 90% confidence interval. And if you recall, we already calculated the z sub alpha over 2 for 90%, and that was at 1.64. So we know that mu is going to be between the 11.091 minus that 1.64 times our population standard deviation. So that's that 14.405. And do you remember what it's divided by? Square root of the sample size, so square root of 30. And then over here, we're just adding that margin of error. Now when we calculate this, still we want to keep our values rounded out to the nearest thousands. So go ahead and calculate those two values. All right, so hopefully for the lower value, you were getting a 6.778 once we round. And the upper value of 15.404. So there's our interval, and remember we're going to write out this summary. And it always starts with, one can say with 90%, whatever confidence level we're dealing with, and in this case, 90% confidence, that the population mean will be between these two values. And remember, it's representing money in 30 credit unions. they're in the millions of dollars. All right, so now let's take a look at calculating sample size. So sample size also is closely related to statistical estimation. The question is, though, how large a sample is necessary to make an accurate estimate? Well, this depends on three things. Now, again, because we're in this section, we're assuming that the standard deviation of the variable is known, or it has been estimated from a previous study. So the first is the margin of error. And if you recall, that's that value that we add on to and subtract from our sample mean. So that's just that z sub alpha over 2 times our population standard deviation over the square root of n. This is why we need our population standard deviation to be known, because our sample size depends on it, because that's part of the formula here for the margin of error. And we need our z sub alpha over 2, which means we need to know our degree of confidence. So the formula for sample size comes from this formula for the margin of error. But notice our sample size is n, so we just have to rearrange it to solve for n. So what we're going to do first is just multiply both sides by the square root of n. Then divide by e. And then square both sides. So our sample size n is equal to this quantity, z sub alpha over 2 times sigma, the population standard deviation, over e, that quantity squared. Now in this case, we always want to round up. Now, a few facts about finding sample size. The biggest, though, the size of the population is irrelevant. When the population is large or infinite, and sampling is done with replacement. All right, so our last example is going to focus on finding sample size. So in this example, a scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From a previous study, the standard deviation of the depths measured was 4.33 feet. How many measurements will he need to do this? So notice it says a standard deviation, meaning of the population, so that means sigma is that 4.33. 99% confidence means our z sub alpha over 2, as you recall we already calculated this, is 2.58. And then this 2 feet, that's the E. So now we could say our sample size n is equal to our z sub alpha over 2, so 2.58, times our standard deviation here, 4.33, divided by 2, and then we square it. So go ahead and calculate that. And remember, we always want to round up. So first write out what n comes out to approximately, and then we'll say the sample size is the value after we round. All right, so you should be getting a 31.2, which means our sample size should be 32. Always round up. All right, so as I mentioned earlier, this was the rest of the topics remaining in section 7.1. So between today and tomorrow, continue working on all of worksheet 7.1. I will have all of the solutions posted tomorrow, so you could check, correct, and ask me questions. Take care, guys.